Hello everyone and welcome to our webinar today on the latest and greatest release of KDB Plus 4.1. My name is Michaela Woods and I'm your host for today's session, and joining me is Andrew Wilson, who's going to tell you all about what's in this release. For those of you who don't know, Andrew is one of the key developers in our engineering team, and he's played a really crucial role in shaping this release along with the rest of our super talented core team. So it's a really exciting time for us at KX. I'm really thrilled to have you all join us today to learn about the new advancements, specifically in this release around performance, security, as well as usability. Just some housekeeping things I'll go through before handing over to Andrew. The first one is we will have a dedicated Q&A session right at the end of the webinar. We should leave about 15 minutes for that. So please submit your questions. You can use the chat box on the right-hand side of the screen, and we'll address as many as possible during that, and then we'll follow up after for any we miss. Secondly, this is being recorded, and the recording will be available to everyone afterwards. Most likely we'll probably post it on YouTube, so you'll be able to share with any colleagues or contacts or go back and revisit it yourself. So that's it for me. I'm going to hand over to Andrew, who you've actually all joined today to hear from, I'm sure. So take it away, Andrew.
Thanks, Michaela. I'll just share my screen. Well, thanks to everyone for joining. I'm Andrew Wilson, and I'm part of the core team here at KX. We're the group responsible for developing and supporting KDB+. Today, I'm going to give a quick introduction to KDB+ version 4.1, and we're going to look at some of the main features of this release, which is now GA. I assume everyone here is familiar with KDB+. The characteristics of KDB+ that people typically focus on are its speed, particularly on very large data sets, and its ability to make sense of time series data. However, some equally important features that I'd like to highlight are its unified environment, which covers the entire data pipeline from ingestion and storage through to analysis. Its ability to bring together different data sets for analysis, including merging streaming data in memory with historical data on disk. Its flexibility in enabling a wide range of different architectures and use cases, and of course the Q language, which helps enable all of the above, and as an array-oriented language maps perfectly onto our vector-oriented data and our column-oriented database. Many of the features in 4.1 were first unveiled at KXCon in Montauk last summer. These features have been gradually released into our test version, 4.1T, where we've received a lot of great feedback from users and an increasingly popular request to remove the T from 4.1T. So KDB+ 4.1 was released GA on February 13th with a focus on scalability, performance, usability, and security, all of which you should see reflected in the features today. 4.1 is available right now via the KX portal and via the Personal Edition download, where it'll work with the Personal Edition license. It's also available via downloads.kx.com for users that prefer that channel, as well as the Anaconda distribution platform. 4.1 is also being integrated through the rest of KX's products. So where KDB is embedded, these features have become available through the upcoming releases of each product. So KDB.ai, KX Insights, and PyKX. There's a huge number of new features in 4.1. We're constantly working to improve the product. Today, I'm going to focus on the items that we expect to have the biggest impact. So that's multi-threaded data loading, parallel processing enhancements, unlimited network connections, persistent HTTP connections, enhanced TLS features, improved at-rest compression, and finally some new language features. These features and more are captured in the detailed release notes, which are summarized on code.kx.com. I would encourage people to check out some of the smaller features in your own time. A few nice ones that I'll mention. We have a generalized database load.q.lo, which allows us to selectively load files and change working directory when we load a database. We've got improved timestamp precision for the system wall time, which is up to full nanosecond precision now on Linux. And probably the feature that got the biggest reaction when we unveiled it at KXCon, automatic console sizing, which saves users from having to work out the maximum number of rows and columns that will fit their terminal screen. For most users, there should be little to no code changes required for this upgrade. The list of NUCs here is very small, and again, it's well documented inside the release notes. Okay, we'll start by accelerating the ingestion of data into KDB Plus via multi-threaded data loading. What we've done here, we've added multi-threading to our ingestion primitives at a low level. This allows us to take full advantage of multi-core, multi-channel hardware, which maximizes throughput. Most commonly in KDB Plus, we'll find ourselves loading data from disk. It's time series data in CSV format. But this feature will also improve performance for other types of delimited data, as well as fixed width text files and binary data. No code changes should be needed to take advantage of the feature. If secondary threads are available, we'll automatically use them to get data into KDB Plus faster. Now, people's mileage may vary, but you can see in the code snippet below that this should make a significant difference to ingestion times. All of this means you'll be getting to the fun part of actually analyzing the data sooner. We'll continue the theme of multi-threading with improvements to our parallel processing framework. There's two major improvements here: nested parallelism and the augmentation of our current round-robin scheduler with a work-stealing algorithm. Again, you can see from my example here that this can lead to significant speed-ups. Keep in mind that that improvement is built on top of already parallelized code. Parallel processing currently in KDB Plus is carried out either explicitly via calls to Peach or implicitly through the use of multi-threaded primitives. In both cases, we will split up a task in such a way that it can be processed by multiple threads working in parallel. In the case of multi-threaded primitives, if we have large vectors, we'll split them up such that we can kind of work on different parts of the vector at different times and pull it all together at the end. Again, all transparent to the users. In this diagram, which will become important in a minute, the different colors represent different threads of execution that the work is being carried out at. So, what does nested parallelism look like in 4.0? Well, the short answer is it wasn't possible. We used round-robin scheduling, which meant we could only split a task up for parallel processing once. After we decided to Peach a job, we couldn't then take advantage of Peach to further split up tasks into subtasks. The only way to achieve something close to that was to redesign your algorithm to completely split the task up front and then pull the results back together at the end. And that would often leave the complex and difficult to maintain code. Even then, you couldn't take advantage of multi-threaded primitives inside Peach, even if the vectors were large and we had plenty of free threads available. With 4.1 though, the limitations on nesting have been removed, so we can call Peach within Peach iteratively. We can even take advantage of multi-threaded primitives inside already multi-threaded code. That leads to a much better utilization of CPU cores, which leads to reduced processing time. Also leads to a much more colorful diagram. Furthermore, we no longer need to worry about our code not splitting the work evenly across cores thanks to the work stealing algorithm. This allows a dynamic redistribution of work across threads. So prior to 4.1, we would assign jobs to threads up front, and if one thread was lagging behind all the others, the whole task would have to wait until the last thread was complete. In 4.1, the initial work is distributed in the same manner as before. In fact, the number of tasks can actually increase now due to the nested parallelism. However, if a thread finishes its share before the others, it can pick up the unfinished jobs from the remaining threads. This is most useful in edge cases, so even in the sort of pathological cases, we shouldn't be left waiting on slower threads. Again, no code change is needed to take advantage of these improvements. In fact, they should provide a good opportunity to make existing code simpler as well as faster. Unlimited network connections. A common request that we've had from users, particularly those users with large enterprise deployments, is to increase the number of network connections possible for each single KDB Plus process. Prior to 4.1, KDB Plus was limited at 1,022 connections per process. However, with 4.1, we've effectively made the number of connections unlimited. The only restrictions now come from the underlying protocol itself or the system settings, such as limits on the number of open file descriptors. So working on the principle of go big or go home, we've successfully tested this with over 1 million sockets into a single KDB Plus process. We recognize that this is probably extreme for real-world systems because other factors are likely to limit the connections, but we wanted to be sure that the limiting factor was not KDB Plus's network stack. Additionally, the limits on file descriptors have been removed and all socket descriptors are now equal. So user code no longer has to avoid using up the lower range of file descriptors when managing files on disks. That should make writing I/O libraries for KDB Plus a lot simpler. And for our Mac and Linux builds, when a process has a large number of connections, the performance of each socket connection has been significantly improved with multiples better throughput. This should see a benefit even if not exceeding the previous limits on the number of connections. The code snippet here should give an indication of the sorts of throughput improvements that are possible. And again, no code changes should be necessary and simpler code should be made possible by these changes. These changes should make a difference in sort of large horizontally scaled systems with lots of processes, such as those we see a lot in the cloud now. They should also simplify architectures where we have a large number of clients connecting to KDB Plus to access data, removing often the need for gateways. Network efficiency should be improved further by the addition of HTTP persistent connections to KDB Plus servers. In web communications, a significant part of the overhead is the need to create a new connection for each HTTP query. With persistent connections, we're going to allow an HTTP client to connect once and then send and receive multiple requests and responses without needing to reconnect each time. In this case, we do need a code change as the default will remain to close the connection each time. The persistent connections are enabled via .h.ka or HTTP keep alive during the processing of the HTTP request, so in the handlers .z.hp, .z.pp, etc. .h.ka allows us to set a timeout in milliseconds, which is delivered as a keep alive value in the connection header returned to the client. .h.ka can also disable the keep alive by passing a value of 0, which will return a connection header of close. You can see in this little snippet here that we have returned a timeout of 2 seconds, and using the curl as our HTTP client, we'll send 2 requests in, and we'll get the 2 responses on the same connection without needing to reconnect. As HTTP connection becomes increasingly popular, particularly in the cloud through protocols like REST, this change removes a lot of the overhead of the communication. As you can see here, this leads to increased throughputs and reduced latency, and generally an optimized utilization of resources. One situation where the overhead is particularly significant is in secure HTTPS connections. Here, the TLS handshake means that certificates need to be exchanged, protocols need to be agreed, and all that happens before any communication can take place. In TLS, we've made a number of additional enhancements. Firstly, by adding support for the latest versions of OpenSSL. We now support OpenSSL up to version 3, including maintaining support for the earlier versions. We'll also dynamically detect different versions of OpenSSL and will preference the most up-to-date library. So that makes the configuration of TLS much simpler. TLS encryption will work with both TCP and Unix domain sockets via UnixS. And finally, we've enabled the use of TLS messaging now on threads other than the main thread. So this allows for secure QIPC and HTTPS communication in multi-threaded input mode. It also allows for client HTTP requests and one-shot synchronous messages via Peach. I'll fire my little Pac-Man animation here. So as encrypted communication becomes increasingly common, it's even required in certain industries. These changes will make sure that we can use the latest encryption methods with minimal fuss, and we can do so while keeping great performance. Another area where we want to be able to use the latest algorithms is in data compression. In 4.1, we've added support for the Z standard compression algorithm developed at Facebook. Z standard then is implemented as algorithm 5 in the KDB Plus compression suite, and it's utilized in the usual way with the triple of logical block size algorithm and the level parameter. It's available selectively, of course, on a per file basis or by setting the default compression parameters in .z.zd. Z standard is a very configurable algorithm which allows users to optimize based on their needs. Compression algorithm -7 level is the fastest, but 22 gives the best compression ratio. That brings a total of 5 compression methods supported by 4.1. We've seen some really good results from testing, and feedback from users has confirmed this. The compression ratios are equal with the best we've seen. The speeds of compression are also very good, though they vary a lot with the level parameter. The decompression speeds are also good, but not quite as good as LZ4. So we recommend users test out different algos and settings depending on their specific data and their hardware and their needs. But a basic rule of thumb might be to use Z standard if compression ratios are important, or if you're using slow storage, and to continue to use LZ4 if the query speed is the priority and your storage is performant. And now we get to the interesting part. KDB Plus 4.1 adds some significant new features to Q, which are designed to improve the expressiveness of the Q language. Specifically, we've added dictionary literal syntax, pattern matching, type checking, and filter functions. And now I'm going to do something quite mad. I'm going to attempt to give a live demo of these features. So
thanks, Andrew. Just while you're getting that up, just reminding everyone who might have joined a little late, we will be hosting a Q&A session at the end of this. So there's a chat box on the right-hand side of your screen, and you can just click on that and post any of your questions in there, and we'll get to as many as possible. So yeah, thanks.
Thanks, Michaela. So yeah, no safety net here. We're going straight into the terminal. I'm going to start with the newest language feature of dictionary literal syntax. Prior to 4.1, if we wanted to define a dictionary in KDB Plus, we had to build one. We built it explicitly by associating a list of keys with a list of values of equal length. With the new syntax, we can actually define dictionaries directly with the following more intuitive syntax. The most obvious immediate advantage of this is that we can quickly associate which keys are matched with which values. The syntax rules for this are consistent with the existing list and table literals. So if we leave out our keys, we get default key names. If I create a few variables, we get implicit column names. And probably best of all, we can leave out values, and consistent with list literals, what we'll get is a projection. So I'll create a trade record. I'll leave out the price, and I'll leave out the size. Let me call this TR for now. What we have here is actually, it's not a projection, but a composition onto a projection. And now what we can do is we can fill in the values we can fill in the values and create a dictionary. We can also fill in a list of values and create a list of conforming dictionaries or a table. So you can probably already see lots of ways in which this will make a lot of existing code cleaner. And we'll see in a moment that it interacts really well with some of the other language features. In my opinion, though, it's worth having this feature just for the following. It gives us a more concise way of writing the following, a singleton dictionary. Previously, we had to enlist both sides, which led to a lot of people doing stuff like this, which admittedly is shorter, but I think you could hardly argue is any more intuitive. Now, we can say exactly what we mean, and we're still getting the same thing. Next thing we'll look at is pattern matching. Pattern matching is really a generalization of assignment. Assignment in KDB Plus is traditionally very simple. We assign one value to one variable. A gets 1. What is A? It's 1. The first thing that pattern matching allows us to do is make multiple assignments at once. A gets 1, B gets 2, C gets 3. I'll do a slightly more interesting example. So here we're assigning different types, and we've got name, age, address. What we see on the left-hand side here that I'll highlight is what we call a pattern. And here the pattern is a list, but it doesn't need to be. If I go to our example from earlier of a dictionary, TRD, if I use a dictionary pattern with a variable, SM, I can assign directly from the dictionary. Now, on the left-hand side here, I've used the new dictionary syntax, but I could just as easily have used the old dictionary syntax, again, with two variables that I want to assign to. And here we assign to date and price. We can even, if I go back to our trade table example, we can even assign directly to a table pattern. So here I'll say size SC, straight from trade, and I'll pull that out of the table. Probably the most useful place that we're going to use patterns is in defining the parameters of functions. So if I define a function here, let's see. This function takes two arguments, but the second one will be used to initialize two parameters inside the function, T and F. If I run it, works fine. If I use a slightly more terse version with false, we can see that T and F are being passed in as a single argument now.
Andrew?
Yes?
This is really good. We actually had one question come in that's related to the syntax, so I might just ask that one while you're in the terminal now.
Go for it.
So Francisco from Habla has asked, when you build a dictionary, are the brackets needed? So I think this was going back to the enlist example where you showed the singleton.
So yes, the syntax is very similar to the table literal syntax. In a table literal syntax, the columns go here. For a dictionary literal syntax, the keys and values go here. So between the parentheses and the square brackets. So again, from earlier, these pieces here form the beginning and end of the syntax. So yes, quick answer that they're critical for the new syntax. Prior to this, that was meaningless. So this isn't a knock in any way. This doesn't change any existing code. This is purely additive.
Perfect. Thanks. Sorry to interrupt.
No, thank you. So we've been assigning with patterns, and that helps with clarity. But pattern matching goes further. It actually allows us to validate that as we assign. I suppose the simplest type of validation is on length. If we use a list of variables and a list of values, if those lengths don't match up, we're going to get a length error. Same the other way. And we also need the keys that we try and match in the pattern to be there. So again, if I just try and get the side out of this record. Here we'll try and get the side out of a thread record, which is a perfectly fine thing to do, except that this thread record doesn't have a side in it. So what we get is a match error. So again, we can validate the data as we assign. And in that case, the assignment failed because there's nothing to assign. We can also check the values in the pattern as we assign. So here I'll use a list. You'll notice here, as well as a variable on the left-hand side, I also have a value. And if that value matches the equivalent value on the right-hand side, then all is well. And val gets 12.34. If, however, they don't match, then we'll fail with a match error. This is useful for making assignments as we aren't sure whether or not the data will be valid or not. What we can do if we don't want to validate a piece of the data and we also don't want to assign it to a variable is we can just leave that slot blank. And if we leave it blank, it'll match with anything. It'll even match with error.
Andrew, I think people are loving your live demo, so I'm so excited you decided to do it. We've got like a few more questions in on specifically the examples. Would you prefer we just held everything to the end, or you want?
No, go ahead. Go ahead.
So Roger Clark, that name's familiar. He's asked, does pattern matching assignment work in a function for local variables?
Yes, it does. Quick answer, yes.
Cool. And Alvi from Balniasny asks, does the new dictionary literal syntax require the key list to be of type symbol?
It does, yes. Yeah, similar to creating column names. We need symbols in the keys in that case. So if we're creating a list of, say, inst longs or and any other types, then we're back to the old syntax. So it's really for that sort of name to value association that this new syntax is the most useful.
Perfect. And there's a slightly more detailed one from James. He's got an example if you want to open up the questions, but he's asked, in pattern matching assignment, are those variables assigned to the global namespace? For example, you can see this example here where he's doing A, comma, B at the end, and he's asked what's the value of A and B here in this example.
Oh, I believe we follow the same rules as single assignments. So double colon for global assignments, single colon for locals. So we're assigning their globals at the start and locals in the next section.
Okay, perfect.
Okay.
Great. Yeah, that was it on those bits. Cheers.
Okay. So data validation, a new feature that people have asked for a while, type checking. Let me go back to my previous example. There we go. When we assigned these three variables, we assigned three different types, a symbol, a long integer, and a string or character array. With type checking, Within the pattern, using the following syntax, we can actually assert what we expect the types to be. We use the same characters, although I'm using symbols to define them, as we use in meta or in .q.t. So here we expect a name to be a symbol, age to be a long, and address to be a character array. And as long as they all match, which hopefully they will, the assignment goes ahead as planned. If, however, they don't match, so let's try and assign Marge. And let's say we accidentally put her name in as a floating point number instead of an integer or long integer. Now the assignment fails, and we still have Homer. If we want to use type checking on a single variable assignment, we can do it. We just have to use parentheses around the variable to create a sort of mini pattern. So we can do that, which lets me do that, which I've always wanted to do in a live demo. Homer J. Simpson, my hero. We can also use these type checks in function parameters. So again, I'm going to go back in time to my earlier example. So if you remember here, this B is a condition, it's a Boolean. And I'll insist that the values for the true and false values will have to be symbols. So now, if I use the first example from earlier, all is well. But if I use that slightly more terse version with the characters, we fail. We fail, it's obvious why we failed, and the function itself didn't run. We can actually take this further, this type of data checking, through our new feature, which are filter functions. Now, whereas in type checking, we can just check the type of the pieces that we're assigning. In filter functions, we can actually put a function into the middle of the assignment operation. And if we want to signal an error as part of that function, then the assignment won't go ahead, a bit like the type check failing. This is a generalization of that. So this time we can check more complicated things. So what I'll check here is the range of data. If I pass in a vector x, and I want all the elements of x to be within the range 0 to 100. If they are, I'll just return the value itself, but if not, I'll signal a range error. So now I'll assign some values, vals, and I'll apply the filter function during the assignment range check. So as long as all these values are within the range 0 to 100 inclusive, which they are, the assignment goes ahead, all is well. However, if I tried to assign 101, and we signal that range error. If you look at the range check, as well as signaling error if things go wrong, I return X if things go correct. That actually gives us an opportunity to do things to X. So we can actually change the value of what we're assigning as we assign it. So filter functions are more powerful than you thought. Let me come up with a silly example, add 10. And I'll get the variable X, apply the filter function, add 10, and I'll assign 1 to X. But what X actually gets is 11 because we added 10. It's a good opportunity to show you that although I've put the name in here, it doesn't have to be the name. If I wanted to assign the Y, I could use a lambda. I could even just use a projection. I'll move my cursor out of the way, sorry. So there's a lot going on here. I'm passing in the values 1, 2, 3 to the pattern X, Y, Z. However, I'm using filter functions for each variable assignment, add 10, the lambda to add 100, and the projection to add 1,000. So what I ultimately end up with are X, Y, and Z, 11, 102, 1,003. We can get even madder than that. We can change the type of the data that we're assigning. So string check. Let's assume that the data we're passing in is a string, but it's the string representation of a number. So we want to cast it to long. What I can do now is I can assign to the variable num with that filter function, and I'll pass it the string 101. But num gets the value 101. And we can validate at the same time. If I redefine that function and I'll say, what if that doesn't work? What if the assignment or the cast rather fails because s is not a valid number? Well, I can check if it's a null. And if it is a null, I'll return a, what do we call it? We'll call it an invalid error. Otherwise, we'll return x. I'll define the cast to be x. So now again, we can assign the string 42, and num gets the value 42. But if unfortunately, we don't have any AI here, so if I apply the word 42, that's going to fail as invalid. Now, we can actually go deeper than that, but I think in the interest of sanity, I'll pull us out of the weeds now and back to the safety of PowerPoint.
Just before you go to the PowerPoint, we've had more questions come in on pattern assignment and filter functions, so maybe we'll hit a few of them just before. So Sean Murphy from JP Morgan asked, do iterator functions work with the new pattern matching, i.e. if you have 3 filter functions and a list of 1 element, can you use each right?
I see. I don't think we do that currently with no, I don't think the syntax allows that currently, but it's something we could look at.
Okay. And Nick Saris has asked, can pattern matching assignment be extended to work with the comma operator so all remaining elements are assigned to the last element?
There are some, that's something we're looking at. There are some extensions to this syntax that are, I guess, NYIs at the moment. Yes, ultimately pattern matching sort of inverts functions. So there's a lot of the pattern is kind of the opposite of the construction. So there's a lot of different avenues that we could extend this down. Some are less bijective than others. So comma is one. Whether or not it's greedy or not. But these are things that we're looking at for sure.
Okay, cool. And Michael has asked, he's got 2 different questions on type checking specifically. So the first one is, can you check for any integer? So short, int, or long, or does this require a filter function? So can you check for any integer type?
There's an extension that allows you to do multiple checks. And again, specifically what he's asked for is something that we've looked at as a possible extension in and of itself. But of course, everything's possible through filter functions. But yeah, I mean, basically that's something we've looked at, and there is an extension that lets you do that without filter functions that's covered in the release notes.
Okay, cool. And is the question from Don a similar one? Can type checking in function signatures handle multiple types for a single parameter?
Yeah. There is an extension to do that, and filter functions can do it.
Sounds like people.
There's a good bit more to this than I was able to show now. Partly in the interest of time and keeping it simple, but everything should be covered in the release notes, and actually, I think in your accompanying blog, Michaela.
Oh yeah, so just to mention, if anyone hasn't seen that, there's an attachments link on this webinar. You can click on that, and there's links to the release notes and also the blog announcement, which has some more detailed code snippets, as well as a place you can give your review. So do check out those links. We have one more on pattern matching from David at Data Intellect. Does pattern matching auto-convert between primitive types like integer to long?
I'm not sure I get the question. Pattern matching is by which do we mean type checking, I suppose?
He says auto-convert. I'm not sure it's...
I think the rules of assignment individually are the same as for the old style assignment. if we're talking about sort of addition and promotion, promotion of things like that. If we're talking about the type checking, then no, it's strict type checking. And I think that kind of alludes to the question earlier about could we just look for any integer type or any numeric type, things like that. That's something we'll look at, and it is possible now in a couple of different ways. But there's always the very flexible way of filter functions, of course. So is type in this list, for example.
Yeah, and I'll just do one last one on the pattern matching questions, and then we can go back to some of the other general questions. Aaron from Morgan Stanley, I think this might be an answer on filter functions can be extended to do this, but is there a syntax for trying multiple patterns and using the first one that matches?
Yes, yeah, that's the extension that I mentioned earlier. That again is covered in the release notes, so that there is a syntax for that. I'm not going to go through it right now because I don't have an example lined up, but yeah, it's possible. And cool. There is an example. I think there might be an example in your blog, but if not, there's definitely an example in the release notes for Perfect. Exactly that use case.
Brilliant.
Okay, back to PowerPoint.
Back to PowerPoint. And after all,
I think I only have maybe one slide left anyway. Maybe we should have just done this a moment ago. Okay. We're back to PowerPoint, yeah?
Yeah, I can see it now.
Okay, great. So hopefully that was useful. I think the main thing is that these features create a more powerful vocabulary for Q, which makes it more expressive and hopefully makes it more effective for solving problems. I mentioned a few times in response to the questions the release notes, the official release notes, which again are summarized really well on code.kx.com, and again the blog, your blog, Michaela. Both of those sources give a good technical description of the new language features and have a number of examples. And that's it. I'll say before I finish, this release 4.1 was a serious effort and a significant achievement for the core team. So I'd like to acknowledge the hard work of my colleagues there. It's James, Simon, Pierre, Oleg, and Charlie, of course. I'd also like to thank the other teams at KX who helped us get this to GA, both technical teams and non-technical teams. And finally, I'll say, we benefited immensely from the feedback that we've received from our users in testing 4.1 and in continuing to give us feedback now that we're in production. So a sincere thank you to everybody who's helped guide us to this release. And that'll be it from me.
Thank you so much, Andrew, and for your braveness to do the live demo. That got so much engagement in the chat. So I think people really appreciated being walked through a lot of the code. We can do a version 2 of the Q&A if that's okay. We've got some time left on the webinar. We've had questions come in as you were talking. These are more general 4.1 related questions. So we've got one from Will at Deutsche, just an overall question. What happens if a 4.1 instance talks to an older version using new syntax? Will it just throw an error? Is there a way to disable new language features?
Could you repeat that? I can't actually find the question.
It's in the prioritize section. You might see it if you see that at the top. I've moved it to prioritize.
Okay, sorry.
But I'll repeat
Yes, go again. Okay, this is from Will, yeah.
From Will, yeah. So what happens if a 4.1 instance talks to an older version using new syntax? Will it just throw an error?
Yeah, so first of all, these changes are additive. So no NUCs rather should be created from using this, but obviously, therefore, the new syntax doesn't mean anything in the old versions of KDB+. So yeah, if we ask a question using the new syntax, it's basically like typing it into the command line, and we'll get an error.
Perfect. We've got Enoch asking, when will there be an ARM 64 build, which opens the opportunity to better control AWS cost using their ARM-based EC2 and the link to Graviton?
There is an ARM64 build now. It was released, so it's available. It's available on all of the usual platforms that we support. This may be a question about KDB Insights. So I guess the answer is, I believe in the next release this will be available, and most of the features should be available there, and that will also be available with an ARM64 build. So the ARM64 Linux, of course, but also we have the dual build for Mac, so we support both the x86 and the M1, M2 series of ARM chips for Mac as well in a single build.
Perfect. Nikita's asked, was anything done to improve the speed of garbage collection in 4.1, as they found it feels much faster?
There were a few small changes. The main change actually was to add some configurability to the garbage collection. I forget exactly what the parameters are now, but we can be more or less greedy essentially with the garbage collection. But yeah, there are some small changes there.
Cool. And then we've got two questions around socket performance. It might just be easier if you read those out. They're quite lengthy. There's one from Jeremy Lucid and one from Sean O'Hagan. So Jeremy's asking, does socket performance improvements apply to both synchronous and asynchronous messages? I think the answer is yes. Is that correct?
There's a few different socket performance things there. What we're really talking about, yeah, so I guess Sean's basically the same question, is it, or very similar?
He's asking for like specifically what's improved.
Yeah, so the changes in socket performance comes from a rewrite of the dispatch loop that we use internally, and I suppose the polling mechanism that we're using. So yeah, it shouldn't matter on the protocol. We should feel it for all the different protocols. And yes, therefore both the sync and async messages. Essentially, the performance is unrelated to the remote process. It's the server, so to speak, where the improvement is made.
Great. Very good. This one, there's another question from Don about a future feature request. So he's asked, are there any plans in the future to create an immutable string type that is treated as an atom but is never interned as a symbol?
Future plans? Well, let me answer this more generally before we get a stream of
requests
questions in here. All of the changes that we've made here are responses to questions just like this. So if there are use cases that you're having difficulty with that the specific features would help solve, please do ask us and give us a description of what the problem is and how we can solve them. We can obviously take this list away. But there's a few things that we're looking at for, I'll call it 4.2, but nothing is even close to set in stone at the moment. So I guess we're open to requests, open to ideas. No promises. Everything will be considered.
Cool. And we got one from Dimitri here. What security features are added to 4.1?
So this is mainly around the enhancements to our OpenTLS support. So supporting the latest version and the latest, I guess the dynamic loading of those libraries, improving the flexibility, or improving the configurability. The other changes around security are obviously around sort of performance while using secure connections. So some of the socket changes, the HTTPS persistent connections, and the ability to use TLS communication on secondary threads.
Cool. We've got a question on I think I've just gotten rid of it there. There was one that just came in on documentation specifically. So Michael's asked, are the IPC protocols documented online? The version 3 is implemented in C.Java, but the big message one and now version 5. Is that?
Again, I guess I'll answer this more generally. I think I know what he's talking about there as well. We're actually in the process of updating some of the documents at the moment. both with some of the retrospective changes and obviously getting the enhancements to 4.1 sort of really thoroughly documented. I guess if there's anything you think is missing, again, let us know. Let the tech team know or the librarian know, and we'll try and enhance it. But yeah, the IPC protocols are documented. If there's something missing, we can take a look. But the idea is for everything to be documented there.
Perfect. And then we might just take one last one from Alvi. Is there any significant overhead with type checking? Is it safe to use in ticker plants, for example?
Obviously, there's some overhead. There's a check that we didn't need to do before, but it should be quicker than if you'd implemented it yourself, via kind of convoluted function. Is it safe to use in ticker plants? I mean, I guess the quick answer is it depends. If your ticker plant's on the limit of throughput that it can take, then this is going to add extra overhead for each message. Maybe that's worth it. Maybe it's not. Maybe type checking downstream or type checking after aggregating data is a better idea. It should be as small an overhead as we can get. And if you don't use it, then there's zero overhead. So if we continue to use code that was compliant in 4.0, then there should be zero overhead. But obviously there's some overhead in type checking, yes.
But if you're kind of doing convoluted type checking at the minute that you want to speed up, then this might be ideal for you.
Exactly, yeah. So I know some people do sort of homebrew solutions to this. This should be faster than those for sure.
Perfect. Okay, I think we can wrap up there. And I just thank you all for being part of today's webinar. Again, just do check out the attachment sections on the links to the release notes, again, blog announcement, and to share your review on KDB+. And just another reminder that this webinar was recorded and we'll make that available to everyone afterwards. Also, we are going to be doing some in-person meetups soon. Very exciting to announce that. We're hoping for around April timeframe. So do keep an eye out for that in your emails, and also we'll probably be posting on socials for that. And just want to say a huge thank you to Andrew for taking his time out of his day to take us through all those exciting updates and doing the live demo. I think it really helped translate a lot of those language features to the audience. And of course, thank you everyone who joined the webinar today. I think we had around 300 people join, which was great, and lots of questions came in. So we look forward to connecting with you in the future in different webinars and at the in-person meetups and online as well. So yeah, is there anything else you want to say, Andrew?
No, thanks a lot, Michaela. And again, thanks to everybody for their feedback with 4.1T and their continued feedback with 4.1. Yeah, we rely on our community reaching out in order to kind of help us guide this product. So we really appreciate all of that communication.
Perfect. And we've got some people chatting, thanking you specifically for the live demo. So thanks so much, everyone, and have a great rest of the day.
Thanks, everyone.
Bye.